All right, let's dive in. In a world that's just completely obsessed with AI, there's this one programming language that's taking a very different path, a path that champions human skill. That language is Zig, and this is the story of a craftsman's tool in the age of the machine.
You know, this quote from a developer, it really hits on something that's been bubbling up for a while now. For decades, C and C++ have been the absolute bedrock of systems programming, but their age is really starting to show. Developers everywhere are on the hunt for a modern alternative, something that gives them raw power, but without all the decades of accumulated complexity. And for a lot of people, that search is leading them straight to Zig.
So who is this challenger, really? Well, Zig isn't just another new language on the block. It's positioning itself as a direct contender for C's throne. The goal is to capture the original spirit of C, but, with the massive benefit of 50 years of hindsight.
At its heart, Zig is a general-purpose language and toolchain that showed up around 2016. Its entire design is laser-focused on three big things: making software that's robust, making it as optimal as possible, and making it reusable. The idea is to be a simple, powerful alternative to C, but to do it without the insane complexity of modern C++, or, let's be honest, the famously steep learning curve of Rust's borrow checker. It's kind of like a return to basics, but with a modern brain.
This metaphor is just perfect. Thinking of Zig as a Swiss Army knife really clicks. It's sharp, it's precise, and it gives you total, absolute control. There's no magic happening behind the scenes, no garbage collector, no unexpected memory allocations. But that power comes with a whole lot of responsibility. If you mess up, it is 100% on you. This is a tool that's built for experts who demand precision above all else.
And this whole idea of precision, it leads us directly into Zig's core philosophy, which is all about control. This is what really makes the language tick and what sets it apart from everything else. It's not just a feature list, it's a completely different way of thinking about how to build software.
Okay, so Zig's philosophy really rests on a few key pillars. First and foremost, explicit is better than implicit. This means no hidden anything. If a piece of code needs to use memory, you see it right there in the function call. The programmer literally has to pass in an allocator. You're always in the driver's seat. This, combined with a small, simple language core, leads us to what is arguably Zig's greatest superpower, comp time.
So what on earth is comp time? It's a keyword that lets you run Zig code while the program is compiling. Now, this is not like C macros or some clumsy preprocessor. You are using the full, actual Zig language to generate, check, and even manipulate your own code before it ever becomes an executable file. This one feature, it just unlocks a staggering amount of power. And this single idea, running code at compile time, it just explodes into this incredible array of uses. You can create generic data structures without any special syntax. You can generate super optimized code on the fly. You can even build your own little custom languages right inside of Zig. For a systems language, this is absolutely a game changer. But here's the twist in our story. This philosophy of precision, of total control, and of rapid innovation is on a direct collision course with the single biggest trend in software today: AI coding assistance.
Think about how large language models work. They create this really powerful feedback loop. An AI recommends a popular language, like Python or Rust, because it has tons of training data on it. Then, more developers use those languages, which creates even more training data. This makes the AI even better at that language, which just reinforces its dominance. For a new, rapidly changing language like Zig, this is a huge problem. And Zig isn't just new. It is evolving at an absolutely breakneck pace. I mean, just look at the release schedule. Version 0.12 took 8 months. The very next major version, it dropped just 2 months later. This is what you call high evolutionary velocity. And while that's super exciting for the humans using the language, it is a complete and total nightmare for an AI model.
And we're not talking about small changes here. These are frequent, significant, breaking changes as the language barrels toward its 1.0 release. Core parts of the standard library are being renamed and completely reworked constantly. An AI that was trained on code from just last year is going to be spitting out code that simply won't compile today.
This creates a fundamental issue with the whole knowledge cutoff thing in AI. A model like GPT-4o is basically frozen in time, stuck in the Zig of late 2023. It has no idea about all the breaking changes that have happened since. So it's not just lagging behind, it's actively generating harmful, outdated code that's dead on arrival.
So this collision between Zig's lightning-fast evolution and AI's static, outdated knowledge has led to some really interesting results. including the Zig community deliberately choosing to build its own path, away from the mainstream.
What's happening is a kind of cultural split. On one side, you've got developers using AI to move incredibly fast in big, stable ecosystems. And on the other, you have communities like Zig's, where developers prioritize deep understanding, total control, and, well, craftsmanship, all things that current AI tools really struggle with.
This divide really came to a head with a huge decision. In late 2025, the Zig project executed a strategic withdrawal, moving its entire official codebase away from GitHub. This wasn't just a technical detail, it was a powerful statement of intent.
So why do it? Well, GitHub is all in on commercial AI, like Copilot. It's central to their strategy. Codeberg, on the other hand, is a nonprofit. It's all about classic, free and open source principles. By making this move, the Zig project was essentially choosing to exist in an ecosystem that values control and developer craft over being just another source of data for the big AI training pipeline.
Okay, so where does all this leave Zig in the bigger picture of systems programming? To really get it, we need to look at it next to its modern rivals, but specifically through this brand new lens of AI compatibility.
And when you look at it this way, the picture becomes crystal clear. Zig is fundamentally resistant to current AI because of its philosophy and its rapid changes. Rust, with its huge, stable codebase, has a more symbiotic relationship. They help each other. Go's legendary simplicity makes its connection with AI excellent. And then you have Mojo, a language literally designed from the ground up to be native to the world of AI.
So let's go back to those metaphors, because they really work. Zig is that precise Swiss Army knife for when you need total control. Rust is the big, heavy battle axe. It guarantees safety, but you have to learn how to wield it. And Go, it's the reliable wrench set. Maybe not flashy, but it gets the job done every single time. Every tool is made for a different kind of builder.
Which brings us to the heart of the matter. The decision to use a language like Zig in today's world, it's about way more than just its technical specs. When a developer picks Zig, they're not just picking a syntax. They are making a philosophical choice. They're choosing a path that puts human understanding and direct control first, even if that means they can't use the same AI productivity boosts that other languages get. And in the end, it really boils down to this one crucial trade-off. On one side, you've got the stability in the AI-supercharged world of languages like Go and Rust. On the other, you have languages like Zig, which offer insane innovation and total control, but they demand that the human developer stays fully, completely in command. And that leaves us with a pretty big question. As AI gets woven deeper and deeper into how we all build software, what is the future for languages that are built by their very design for the human craftsman? Will they become a niche tool for specialists, or are they a necessary counterbalance to a world of auto-generated code? How we answer that will define the next chapter of software.